All right. Welcome to today's class where we'll be looking at questions from tutorial sheet 2, which is basically on exponentials and logarithms. Okay, so this is the tutorial sheet. This tutorial sheet is coming from the University of Lusaka. So it has about 5 questions. As you can see here, we have question 3 there, question 4, and then question 5. Okay, so question 1, 2, 3, question 1, 2, 3 are just about the algebra part, okay, the solving part. And then question 4, 5, okay, is about how you can apply the logarithms and the exponentials to to the medical field. Okay, so in the other class, I remember we were looking at some questions on logs. Okay, we were looking at how to convert from the exponential form to the logarithmic form. So I believe none of you has a problem with that. Okay, we also look at how to convert from the logarithm to the exponentials. Okay, so we are not going to take much time on question 1 because we taught this and we were able to solve questions. So let's look at some questions from 1. Okay, so if you have any questions, please feel free to ask. Okay, so we start with question 1a. They're saying express each of the following exponentials as logarithms. Okay, so we said for us to convert from either form to the other, we're going to be using the mnemonic BAM. Okay, so this BAM simply means base to the power answer is equals to what is in the middle. Okay, so when I write my logarithmic form, it will be log base A, and then I put B is equals to C. Okay, so this A here is what we call as the base. Okay, this C is what we're calling as the answer. And then this B here is what we are calling as what is in the middle. Okay, it is in the middle between the base and the answer. Okay, so when converting from the logarithmic form to the exponential, we go this route. We say base to the power answer, okay, is equals to what is in the middle. So that's what we follow there. Okay, so it means our exponential from here will just be A to the power C should be equals to what? To B. So now here we've been given questions that are in this form, and then they want us to convert them to the what? To the logarithmic form. Okay, so we start with the first one. Y is equals to, or let me write it like this. Okay, I'll write it as 2x is equals to y. So we know that this 2, okay, let me change the color. We know that this 2 here is the base. And then this x here, okay, we know that it is the what? The answer. And then this y here is just what? What is in the middle? Okay, so we're going to call our follow base to the power answer is equals to what is in the middle. So it means when I change this to logarithmic form, okay, I can change it to a log of any base. So it can be log, the base is 2, okay, and then what is in the middle is y, should be equals to the answer, which is what? X. So we have converted this 2 to the power x is equals to y to a log form, which is log base 2, okay, y is equals to what? Uh, x. Okay, so we have converted this guy to this. Okay, so if we want to change again to just be 2 to the power this is equals to this. All right, so any questions there? Okay, what about the second one? So the second one, we have y, okay? I should write it as 10 to the power x is equals to y. Again, we see that 10 here will be the base, okay? And then this x here will be the answer. And then this y here will be the what? The middle, okay? So I'll just write log, my base is 10, okay, and then what is in the middle is y is actually equals to what? To x. So this is the answer here, okay, when we convert this guy to a log form. Okay, so it's just going to be uh, uh, a base to the power answer is equals to what is in the middle. All right, so any questions there so far? of what we've done? Any questions there? Okay, if there are no questions, let's look at the fifth one. Okay, so because we're just using the same concept. So this one you can try it, this one you can try it. Okay, let's try out this one. So that one, I'll write it as 4x minus 2 is equals to what? Y. Okay, so we're doing the same thing. Okay, we're doing the same thing. So what are we going to do there? Okay, what are we going to do there? We're going to get our base, our answer, and what is in the middle. So 4 is our base. Answer is this guy, the x minus 2. This one is what is in the middle. So it will just be log of base 4. What is in the middle is y is equals to x minus 2. Okay, so that will be our answer there. So any questions there? Okay, if you want, you can write it as 2 plus log 4y is actually equals to x. So you can write it as this, or you can just leave it the way it is here. Okay, so any problems there converting from exponentials to logarithms? It's very simple, right? Okay, then let's look at questions on B, where we are doing the opposite now. Okay, we are getting questions from the log form, we are taking them to the exponential. So this guy, okay, I'll just write it as log base 2 y plus 3 is actually equals to x. So I see my base answer, what is in the middle. So this will just be 2 to the power x is equals to x plus 3. Okay, it's equals to x plus 3. Or if you want, you can also write it as 2x minus 3 is equals to y. There's no problem. So this was the first one. Okay, let's look at the second one. So here, I'll write this again as log base 10 y squared minus 1 is equals to x. So my base is 10. My answer is x. Okay, and then this should be equals to y squared minus 1. As simple as that. Okay, what about this guy here? So I'll write it as ln y is equals to x. So now this ln y here means the natural logarithm. Okay, so the natural logarithm, whenever you see ln, it's the same as log to base e. Okay, whenever you see ln like that, it's the same as log base e. So this one, I'll write it as log e to replace this ln, and then y is equals to x. Okay, and then when I change it to exponential to just be the base, okay, to the power answer is equals to what is in the middle. So that is the answer there for this one here. Okay, what about the fourth one? So let's look at this one. So we have log base 5, 25y is equals to x. So this will be base to the power answer is equals to what is in the middle. So base to the power answer will be equals to what is in the middle, which is 25y. So this was it, 4. And then 5, I'll write it as log base 4 y over 16 is equals to x. So this will be base to the power answer is equals to what is in the middle, like that. Okay, and this is our answer. So I can leave this one here for your practice. So you try it out. Okay, and then if you have any difficulties, please feel free to contact me. All right, so we are basically done with question 1. Let's look at some questions from question 2. So question 2, we are solving exponential equations on A, and then B, we are solving logarithmic equations. Okay, so how do we solve these exponential equations? We use those laws of indices that we talked about earlier. Okay, when we just started our classes, we talked about the laws of indices, okay, or laws of exponentials. They are the ones that we're going to be using today. Okay, so here we'll be taking advantage of the fact that some numbers that have been given there, they can be expressed at a certain number raised to a certain number. Okay, so uh, if I have a to the power x being equal to b to the power maybe y. Okay, no, I shouldn't do this. I say a to the power y. If I have such an expression, right? So we see that the base here is a, the base there is a. So according to the laws of exponents, okay, if the bases are the same, then it means the powers here should also be the same. Okay, so if I have a to the power x is equals to a power y, then I can easily cancel out the bases. What I'm going to remain with will just be x is equals to y. So this property is what we are going to be using to solve these questions. We are going to be making the base here and the base on the other side to be equal. Okay, so that their powers, we can equate them and then we solve for x. So the first one, we have 2 to the power x plus 1 is equals to 64. So here we want to make this 64 to be a 2 to the power something so that the bases should be the same. We cancel them and then we can equate the what? The powers. So it turns out that 2x plus 1 is equals to, so this 64, okay, you should try out your calculator. It's the same as 2 to the power 6. Okay, so I'll write 2 to the power 6 here. So meaning that I can cancel out these two, cancel out these two, I remain with x plus 1 is actually equals to 6. So x will just be equals to 6 minus 1, which will just be equals to what? 5. Okay, so if x is 5 here, plus 1, that would be 2 to the power 6. Even the other side, the 64, it's the same as 2 to the power 6. Okay, so you can try out doing 2 times 2 times 2 times 2 times 2 times 2, 6 times. It's going to give you a 64. So our answer there is just what? 5. Okay. Any questions there? Okay, no questions. All right. So now let's look at B. Question 2, I mean this one. So there we have 3 to the power 2x is equals to 81. Okay, so we know that we can express 81 as 3 raised to a power something. Okay, so because if we do 3 times 3, this would be 9. Okay, if I do 3 times 3 times 3, this would be 27. If I do 3 times 3 times 3 times 3, this would be 81. Okay, so it means 81 is the same as 3 multiplying itself 4 times. So it would be 3 to the power 4, which is 81. So here where there's 81, okay, I'm going to put 3 to the power 4. So this would be 3 to the power 2x is equals to 3 power 4. And then I'm going to cancel out the bases. So it will be 2x is equals to 4, which will just be x is equals to what? 4 over 2, which will just be 2. Okay, so x there is equals to 2. Okay, what about question 3 there? So we are just using the same principle. So here we have 5x minus 1 is equals to 25. So we know 25 is the same as it's the same as 5 squared. Okay, 5 to the power 2. So this will be 5x minus 1 is equals to 5 squared. So cancel out this, I mean it x minus 1 is equals to 2, which will mean x is equals to 2 plus 1, which will just be what? 3. So x here is actually equals to 3. Okay, so any questions there? Okay, if there are no questions, I'll proceed. So here we have 4x plus 1 is equals to 8x minus 1. Okay, so here we can't make this 8 to be 4 power something. No. And we can't make this 4 to be 8 power something. So instead, we look for a common number, okay? I know that 4 is the same as 2 to the power 2. This is my 4. And then I have x plus 1 outside is equals to. This 8 is the same as 2 to the power 3. And then I have x minus 2. Okay? And then from here, remember from the laws of exponent, we said we can distribute this power to whatever we have outside, right? So this is going to be 2. And then here to be 2 multiplied by x, that will be 2x. 2 multiplied by 1, that will be plus 2 is equals to. Here it will be 2. And then 3 multiplied by x to be 3x. 3 multiplied by minus 2, that will be minus 6. So now we see that we have the same bases there and there. So we can cancel out this, cancel out this. So what do we remain with? Okay, we remain with 2x. Okay, we remain with 2x plus 2 is equals to 3x minus 6. So like terms together, I get 2x minus 3x is equals to minus 2 minus 6. So this is just going to give me minus x, which will be equals to minus 8. So now let's divide both sides by a negative 1. So we get x is actually equals to what? To 8. Okay, so any questions there? Okay, so the technique that we've used here is the same one that we're going to be used to use here and there. So let's do question this one here on 5. So on 5, we have 9x plus 1 is equals to 27, 2x minus 1. So this 9 is the same as 3 squared, and then I put 2x minus 1. I mean, that's what? X plus 1 is equals to 27. It's the same as 3 to the power 3, and then 2x minus 1. So here I'm going to have 3. 2x plus 2 is equals to 3, 6x minus 3. So the bases now are the same. I can cancel them. I remain with 2x plus 2 is equals to 6x minus 3, like terms together. So we're going to have 2x minus 6x is equals to minus 2 minus 3. This will give me minus 4x is equals to minus 5. So divide both sides by minus 4. I get x is equals to 5 over 4. Okay, so any questions there? That's the answer there. Okay, no questions. All right, so I'll leave this one for you to try out. Okay, you can always share the solutions with me in case you are stuck. Okay, in case you are stuck, you can share the solutions with me. Then I'll be able uh, to answer. All right, so now let's look at part B of question 2. So there we were solving questions on exponentials. Okay, so now we are going to be solving questions on logarithms. Okay, so we need to use the laws of logarithms that we learned. Okay, so if you missed that class, there's a video on the website or on the app. Okay, I hope you guys have downloaded the app because it's easier to watch the videos on the mobile app. Okay, you can even download the videos there and you watch offline. Okay, so we're going to be using the laws of logarithms, yes. So we're going to be talking about them as we solve. So the first one, we have log base 2x plus log base 2, 8 is equals to 5. So here they're saying evaluate the following logarithmic functions. So meaning that we are looking for the value of x. Okay, so the funny thing is that if you don't know how to convert from logarithms to exponentials, you can't solve this question. No wonder it was important for us to solve question 1. Okay, so here the laws of logarithms say that if I have the same bases and I'm adding these things, okay, it's the same as I just write 1 log to that same base and then I multiply the numbers that are in front there. So this would be x multiplied by 8. So I get 8x is equals to 5. Okay, so if you missed that video on the laws, please go back to it. All right, and then once I put it here, I convert it to exponentials. So this will be my base. Okay, this here will be my answer. This one will be what is in the middle. So we are back to our BAM. Okay, so base to the power answer is equals to what is in the middle. Okay, so what is 2 to the power 5? So you can punch just on your calculator. 2 to the power 5 is 32 is equals to 8x. So we divide both sides by 8. We get x is equals to 32 divided by 8, which will just be 4. So x here is just 4. Okay, any questions there? Okay, no questions. We look at the second one. So the second one, we have log base 3 x minus log base 3 9 is equals to 1. So the laws of logarithm states that if I'm subtracting two logs of the same base, it's the same as I just write one log to that same base, and then I divide whatever is in front there. So this will be x over 9 is equals to 1. From here, I change to exponential. So base to the power answer is equals to this. So base to the power answer is equals to what is in the middle. So we can say 3 over 1, and then we cross multiply. So it means x will be multiplied by 1. I just get x is equals to 3 multiplied by 9. I get 27. So my x there is 27. All right. Let's look at the third one. So the third one, we have 2 log 5x is equals to log 5, 9. Okay, so what can we do there? Okay, what can we do there? Okay, so the first thing is to use this law. So we said if I have log base AB to the power C, I can actually drop this C, remember? So this becomes C log AB. So on this part here, I'm going to raise this power so that it becomes, I'm going to raise this 2 so that it becomes a power there. I can also drop it, okay, using this law. So this one becomes log base 5x squared is equals to log base 5, 49. Okay, so now here I have log base 5, log base 5. Okay, so there, the bases are the same and there's nothing that I'm adding. It's just a log base 5, even there log base 5. So if you want, you can say cancel out the log base 5, cancel out the log base 5. So remain with x squared is equals to 49. Okay, and then this one will actually give you what? Okay, will actually give you x is equals to the square root of 49. So the square root of 49 is plus or minus 7. So the answers are x is equals to 7 or x is equals to minus 7. Okay, but can x ever be a negative? Okay, can x ever be a negative? Okay, so in this case, this one here, okay, if we just consider the way it is here, it can't be defined if we choose x is equals to minus 7. Okay, it will be undefined because there's no logarithm of a negative number. Okay, so the best answer here is just x is equals to 7. So we can also get this answer by just using the laws of logarithms. So let's say we had log base 5 x squared, and then I get this guy, I take it to the left. So it will be log base 5, 49 is equals to 0. So now I see that the same base is here, and I'm subtracting. So meaning I can say log base 5 x squared over 49 is equals to 0. Okay, so now I can use it. I can turn this into exponential, I mean. So it will be 5 to the power answer 0 is equals to x squared over 49. So 5 to the power 0 is just 1 is equals to x squared over 49. Divide by 1, cross multiply, I get x squared is equals to 49, which will still give me plus or minus 7. But we choose x is equals to 7 because for x is equals to 7, we are guaranteed that this term here is going to be defined. Okay, if you just write it the way it is, not considering the squared there. Okay, so the answer there is 7. So any questions there? Okay, let's solve the fourth one then. Okay, so here we have log base 4x plus log base 4 x minus 3 is equals to 2. So we are adding and we have the same bases. So this becomes log of base 4 x multiplied by x minus 3 is equals to 2. Change to exponential, we get 4 to the power 2 is equals to x squared minus 3x. So this will just give us a quadratic, x squared minus 3x minus 16 is equals to 0. Because 4 to the power 2 is 16. So we just have to solve this quadratic equation now. Okay, we just have to solve this quadratic equation. So are there any two numbers that you can multiply? They give you minus 16, but when you add them, they give you minus 3. Okay, so there are no such numbers, so we can use the formula method. So my A is 1, my B is minus 3, my C is minus 16. So it means X will be equals to, okay, X will be equals to, um, okay, it will be equals to B. Okay, B, what is B? Okay, it will be equals to B plus or minus the square root of B squared minus 4AC divided by 2A. So this is the formula, right? Okay. Is it minus B? Here it should be minus B, not B. Okay, that's the formula. So we're going to say X is equals to minus B will just be a positive 3 because B is already a minus. So plus this minus outside, I get 3 plus or minus. Then in the root here, I'm going to have B squared, which is 9 minus. Here I have 4 multiplied by A1 multiplied by C minus 16. So what do I get there? Okay, I get a minus 64. And then multiplied by this negative, I get plus 64 divided by 2 multiplied by 1, which is just 2. Okay, so that's what I have there. So let's continue from on top here. So we're going to have x is equals to 3 plus or minus 9 plus 64. 9 plus 64 is the root of 73 over 2. So it means x will be equals to 3 plus root of 73 over 2, or x will be equals to 3 minus root of 73 over 2. Okay, so if you have the calculator, you can punch this to get the actual answers. Okay, you can punch that to get the actual answers. Okay, but for me, I'm just going to leave them here. But if you have a calculator, you can punch it, and then you get the actual answers. All right, so any questions there, guys? Okay, let's look at question 5. And then the other one, I'll leave it for you to try out. Okay, then that will be all for today. Um, so we have 5, we have log 6x squared plus 5x minus log 6x plus 1 is equals to 1. So same bases, and we're subtracting. So meaning we're just going to write log 6 and then we divide these things. It's equals to 1. Okay, and then from here we are going to say base to the power answer is equals to what is in the mid. So base to the power answer is equals to x squared plus 5x over x plus 1. Okay, so here we can cross multiply. We get 6x plus 6 is equals to x squared plus 5x. So like terms, or we take everything to the other side, we get x squared plus 5x minus 6x minus 6 is actually equals to 0. Okay, so this will just be x squared minus x minus 6 is equals to 0. And we see that the factors here will just be plus 2x minus 3x minus 6 is equals to 0. Okay, so meaning that we can group them like that. So what is common here is x. And then remain with x plus 2. What is common there is minus 3. Then remain with x plus 2, which is equals to 0. Okay, so it means I have x minus 3, and then x plus 2 is actually equals to 0. So if I equate this to that, I get x is equals to 3. There, I'm going to get x is equals to minus 2. Okay, so we get two answers. X is equals to 3 and x is equals to, okay, so x is equals to 3, x is equals to minus 2. So here we have to choose one answer which is valid. Okay, so for logarithms, whenever you get a negative answer, okay, it won't be valid. Okay, it won't be valid as long as it's linear like this one here. So if I put a negative 2 there, it will be log of 6 minus 2 plus 1, which is minus 1. So log of a negative number does not exist. So we're going to discard this answer here. Okay, we discard it. So our only answer will be x is equals to 3. This one here. Okay, so we are done for today. I just wanted us to solve question 1 and 2. So if there are any questions, you are free to ask. Okay, if there are no questions, I would also like to let you know that, so here we've done question 1, right, and 2. So question 3, this one here, it's already there on the website or on the app. So you can watch how I solved these questions there. It's already there. So I'm only remaining with question 4 and 5. Then I'll be done with this tutorial sheet. Okay, so I'll post an update in the group of when I solve all the questions there. I'll post an update in the group. But right now, okay, uh, these three here has already been solved. So question 3A, B, C, D, all these one here I've solved. So in the next video, we are going to look at question 4, which is very practical, and also question 5. All right, so that's the end of the lesson today. Thank you so much for joining.